So, in this video, we will solve a numerical based on most frequently used page replacement algorithm. So, we are given 3 page frames, as you can see over here. Right? We want to compute the number of page faults. The algorithm which we are going to use is most frequently used, right? And this is the page reference string which is given to us. Okay. So let's start. We are given 3 page frames, so we know that we have memory for 3 pages. Okay, right? Then we look at the number of distinct pages. If you see, the number of distinct pages is 0, 1, 2, 3, 4 and 7, right? These are the distinct pages which we have. And here we will see the count of how many times that page was used. You can say it is a use count. Okay, so how many times that page was used into main memory, use count. Okay, so idea is very simple. What you need is page 4, you take it into main memory. There is a page fault, you take that page into main memory. The page is used. So earlier the use count for all of the pages was 0, but now the page count for 4 will be 1. Okay, next we need page 0. There is a page fault, we bring that page into main memory, the count becomes 1. Right? That will happen for 0. Then we again need page 4. It is already there, no page fault, we simply use the page. But now since the page 4 is used twice, its use count is 2. Because after taking that page into main memory, we have used that page 4 twice. Then we need page 3. It's not there into main memory, so we bring that page into main memory. So we have 4, 0, 3. Right? Since 3 is used, the use count will be okay. Then we need page 0. It is already there, no page fault, we simply use the page. The use count for that page becomes 2. We need page 4. Page 4 is also there in memory, you simply use it, but make sure to increment the use count by. So that's 3. Now we need 1. We need page 1. It is not there in main memory, so we will bring that page into main memory by selecting one of these 3 pages as victim, either 4, 0 or 3, based on the use count. The algorithm is most frequently used, so which page will be selected as victim? The one which is most frequently used. So 4 is used 3 times, 0 is used twice and 3 is used once. The most frequently used page is 4, so we replace 4 with 1, right? So 4 is thrown out and 1 is taken into main memory. So now the use count for page 4 becomes 0, right? And what we do is we make the use count for page 1 as okay. So that will happen for page 1. Next we need page 0, right? We need page 0, it is already there, right? So we simply use it, no page fault, but the use count becomes 3. Then we need page 3. 3 is also there, we simply use it, the count is. Then we need page 2, so there is a page fault. Which page will be selected as victim? 1 has count of 1, 0 has count of 3 and 3 has count of 2. So naturally the highest count is of 0, so 0 is thrown out and 2 is taken into main memory. So 1, 2, 3. Right? So 0 is thrown out, so its count becomes 0. 2 is taken into main memory, so its count is 1. Then we need page 0. Page 0 is not there in main memory, so we have to take that page into main memory. We look at the count of 1, which is 1, count of 2, which is 1, count of 3, which is 2. Most frequently used page is 3, so 3 is thrown out. 0 is taken into main memory. Since 0 is taken into main memory, it is used, its count is 1, and the use count for 3 becomes 0 because 3 is no longer in main memory now. Now we need page 7. Page 7 is also not there in main memory. So we have to take that page into main memory by selecting one of the page as victim. Now look at the use count of 1, it's 1. Use count of 2, 1. Use count of 0 is 1. So all pages have been used equally, right? So there is a tie, right? How you resolve the tie? Using FIFO, that is first in, first out. Now if you look at this, 0 came over here, 2 came over here, and 1 came over here, right? So which page was taken into the main memory first out of 1 to 0 is 1, right? Because right now, whichever pages are there in main memory, you have to see. You see that 0 is taken over here, right? 2 is taken at this place in this case, and 1 was taken over here. So first in, first out says replace 1, right? So 1 is thrown out and 7 is taken into main memory. So it will be 7 to 0. So the use count of 1 becomes 0, use count of 7 becomes 1. Okay. Then we again need 1, right? 1 is not there in main memory. So we have, there will be a page fault. Right? Out of 7 to 0, 7 is used once, 2 is used once, and 0 is also used once. Again, there is a tie. Again, how you are going to resolve the tie? First in, first out. FIFO. 7 taken into the main memory over here. Then 0 was taken over here, right, and 2 was taken over here. So which page will be replaced? Out of 7 to 0, 2 came first, right? So 2 will be thrown out and 1 will be taken in. Okay, so it would be 7 1 0. So the count for 2 becomes 0, count for 1 becomes 1. Now we again need a 2. We have 7 1 0, so there will be a page fault again, right? Out of 7 1 0, 1 just came, right? Then 7 came over here, right? Out of 7 1 0, 7 came over here, 2 0 came over, 1 came over here, and 0 came over here. So which page came first out of 7 1 0 is 0. So 0 is thrown out, right? And 2 is taken in. So 7 1 2, 7 1 2. Okay, so when it is 7 1 2, the count for 0 becomes 0, count for 2 becomes 1. Okay, now we need 1. 1 is already there, no page fault, but since we use it, its count is 2. Then we need 2. 2 is also there, its count is also, okay, it is used. And finally we need 0, right? We need a, so then there will be a page fault. Now out of 7 1 2, the count for 7 is 1, count for 1 is 2, and count for 2 is also 2. So again there is a tie. So how you are going to resolve the tie? Using first in, first out. Now if you look at this, out of 1 and 2, 2 came just over here and 1 came before 2, right? 1 came before 2. So 1 will be replaced. So it would be 7 0 2. The count for 1 becomes 0, count for 0 becomes 1, and that's it, right? So how many page faults we got? 1 2 3 4 5 6 7 8 9 10, right? So total number of page faults using MFU is 10. Okay, I hope you have understood this. Thank you.